We shall see. All right, so converting quadratics into vertex form, the method for this is by completing the square. That's what we call it. Is it easier to read? Yeah? Okay. All right, completing the square. So here are some examples of squares, because I want you guys to know what I mean when I say we're going to be completing the square. So an example of a square is if I have x minus 1 squared. That's a square because I squared it. What do I mean when I say x minus 1 squared? Yeah, x minus 1 times itself. X minus 1 times x minus 1. And what do I get when I multiply that out? X. Plus 1, very good. Okay. So I have x squared minus 2x plus 1. That's what I have. How do you feel about that, Dylan? Do you realize you threw your pencil down when you were done with that? You're like, look at my pencil though! Man. All right. So here's another example of a square. X plus 3 squared, and what is that actually? X plus 3 times x plus 3. And if we multiply that out, okay. So you'll notice here that you always end up, the third number here, the third term, is always a perfect square. Because to get this one over here, we did -1 times -1 is +1. To get this 9 over here, we did 3 times 3 is 9. So whenever you are completing the square, you're always going to end up with a perfect square number on the end, okay? So we're going to say that squares, that x minus 1 squared, that x plus 3 squared, squares are a binomial, I said binomial, but I put a D. Binomial. What do I mean when I say binomial instead of trinomial? I mean 2. So these have 2 terms in them. That's why we call them binomials. Why did I call it a factor? Yeah, because it's in parentheses. It's like factoring, okay? So binomial factor multiplied by itself. All right, so we're going to figure out what number completes the square. So if I have x squared plus 8x plus, it's kind of like we're doing this process, but instead of starting at the beginning and writing it twice and multiplying it by itself, we're going to start at the end and we're going to go backwards. So what would have happened with the 8? It would have been, yeah, it would have been divided in half and been 4 and 4, right? Okay, so we're going to say this is kind of like having x squared plus 4x plus 4x. And so if we think about the parentheses that would have made that happen, we would have had to have an x plus 4 and an x plus 4, right? It's so annoying when it does this. All right, is it up there? Yes. Okay. So if we're going backwards, we have x squared plus 4x, and the number that would have been on the end is 16. So x squared plus 8x plus 16. So when we talk about this 16, this is the number that completes the square. That is the number that completes the square. So if we were to write this in factored form, we would say that's x plus 4 times x plus 4, because we're looking for two things that multiply to 16 but add to 8, x plus 4 and x plus 4, and we would say that's x plus 4 squared. This right here, we would say, is the completed square. So 16 is what completes the square. The completed square is x plus 4 squared. So 16 is the number we use to complete the square. This is the completed square form. Are you just looking at my nails? A little bit. All right, so we're going to do some examples of this. We're going to complete the square. That's what all of these instructions would say. So if I had x squared plus 10x plus something, and I wanted to figure out what number would go in the blank, what am I going to do with the 10? I'm going to divide it by 2, because that's how they got x squared plus 5x plus 5x, okay? So I'm going to say 10 divided by 2 gives me 5. And then what do I do with that 5? Multiply it by itself, right? By itself, okay? Because we're thinking about this having parentheses now that are x plus 5 and x plus 5. And we're saying that 5 times 5 is 25. And so 25 is the number that completes the square. Yep. And so the completed square form would be what? X plus 5 squared. Okay, here's the next one. We're going to do x squared minus 12x, that's an x, and we're going to figure out what number would complete the square. So negative 12 divided by 2 is negative 6, and if you were to multiply that by itself, it would give you 36, positive 36, very good. So we're going to say 36 is the number that completes the square. And if we think about the parentheses that we would have gotten, what would they be? X minus 6. All right, here's the next one. X squared minus 100x. So negative 100 divided by 2 is negative 50. Negative 50 squared. What's negative 5 times negative 5? Yeah, so negative 5 times itself is 25, and then we're going to have 2 zeros. So 2,500. So 2,500 is the number that completes the square, and if we want to write this as a completed square, what do we write? X minus 50 squared. Okay, can I give you one with decimals if I let you use your calculator? Okay, so here's going to be the decimal one. We're going to do x squared plus 9x plus something. Why is this about to be decimals? Yeah, it's an odd number. It's an odd number. So we're going to say 9 divided by 2 is 4.5. Go ahead and use your calculators. 4.5 squared, 20.25. So that's plus 20.25. And then what do we get when we write it as a completed square? X plus 4.5 squared. Okay. So what you'll notice is that every time the number that we divided by 2, the answer that we got when we divided by 2, this right here brings us to our completed square. We divided by 2, we got negative 6, that goes right there. We divided by 2, we got negative 50, that goes right there. We divided by 2, we got 4.5, that goes right there. Does that make sense? Okay. So now what we're going to do is we're going to get back to what this video was really supposed to be about, which is taking a quadratic that's written in standard form and getting it to vertex form, okay? So the standard form of a quadratic is y equals ax squared plus bx plus c, and that's not a bad form for a quadratic, but it doesn't tell us any of our transformations. It doesn't tell us what our vertex is, and it's really hard to find like the increasing and decreasing intervals or the domain and range or all that stuff that we've been finding unless we have it in vertex form, okay? So if you look at the vertex form, that is y equals a times x minus h squared plus k. So you can actually see in the vertex form we have a completed square in there. You guys see that? So the process that we use to get from here to here is we complete the square. That's how we convert the two forms. Does that make sense? Yeah. You have done completing the square in Math 2. You did it to solve equations. You didn't do it for this. You did it in a different context. Yeah. It's actually where the quadratic formula comes from. All right. So example, that was example 4. Example 5. All right, so we are going to complete the square to get the quadratic in vertex form. Complete the square to convert the quadratic into vertex form. So we're going to start off with a quadratic that's in standard form. So y equals x squared plus 6x plus 3. And our first goal is to make it look like it did with the other examples. And in the other examples, we just had x squared plus 6x, right? We just had it like that. So the first thing I'm going to do is I'm going to take this 3 and I'm going to move it to the other side, because right now the 3 is in my way. So I have y minus 3 equals x squared plus 6x plus the space to complete the square. And then I'm going to go ahead and cover this up so it doesn't distract me. All right, so what do I do to complete the square? 6 divided by 2 is 3. 3 squared is 9, so 9 completes the square. All right. Now, this is an equation, so if I add 9 to the right side, what do I have to do to the left side? Add 9. So on the left side, I have y plus 6. On the right side, I have a completed square, which is what? X plus 3. And it's plus 3 because that's what we got when we divided by 2, right? Okay, what do I do now? I want to get the y by itself. Oh, I did. I subtract the 6 over. You were right, I was covering it with my finger. And so our vertex form is y equals x plus 3 squared minus 6, and we're done. It kind of has a nice little rhythm to it. Yeah, it's got like a nice little transition. All right, example 6. Y equals x squared minus 8x plus 7. Okay, so I don't like the 7 there because I want my blank to be there. So I minus the 7 over. And then I cover this up. So what do? Divide by 2. Can't what?
I'm confused now because it's -8, and you can't square something to get a negative.
You don't square to get a negative. We're going to take a negative and we're going to square it to get something else. Because you'll notice when we did all these, our perfect square was always positive. And we did have negative numbers. We squared them and they became positive. So this isn't the perfect square. We divide it by 2 and then we square it and we get a perfect square. So we're okay with the 8 being negative. It's always going to turn to positive. Yeah. Okay, so we have -8 divided by 2 is -4, and then we have -4 squared in 16, and 16 is the number that completes the square. Now this is an equation, so if we added 16 to the right side, we have to add it to the left side. So we have y plus 9 equals a completed square. X minus 4 squared was the completed square. Yep. You subtract it over. Okay, we're going to do a decimal. Y equals x squared plus 5x minus 2. So what should I do? Yeah.
Okay, so first you add 2 to the other side.
Yeah.
Y plus 2 equals x squared plus 5x. Then you divide the 5x by 2, and you get 2.5, and you square that. You get 6.25, and so you get x squared plus 5x plus 6.25. But that ends up turning into y plus 2 equals.
Wait, be careful about the y plus 2, because you added something to the right side.
So y plus 8.25.
There you go.
Equals x plus 2.5, and then you subtract the 8.25 from that side and subtract it from the other side, and you get y equals x plus 2.5 squared minus 8.25.
Perfect. So let's slow it down a little bit. So we divided by 2, we got 2.5, and what do we do with that? We square it. And what is 2.5, goodness gracious? 6.25.
It's not 19, right?
So since we added 6.25 to the right side, we're going to add it to the left side. Y plus 8.25 equals x plus 2.5 squared. And then we can go ahead and subtract this over to get the y by itself.